are going to learn about embedded systems. First of all, we have to know the simple definition of an embedded systems before going into the main part. Here the slide shows what is embedded systems. Next slide will show the definition of an embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. That means embedded systems can combine both hardware and software to do a particular function or a particular task. And next, embedded system is a computational system that is developed based on the integration of both hardware and software in order to perform a given task. That means it is also same as the before point. An embedded system is a small computer designed to perform function within a larger device. It includes both software and hardware to perform a particular purpose, such as controlling functions in car, washing machine or smartphone. That means we can control larger devices by using small computers. And next slide will show which components includes in embedded systems. The components should be basic electronic components, that is resistor, capacitor, transistor, diodes, inductors, thyristors, etc. Basically, resistor, transistor, capacitor, everything should known by an electronic student. And next slide will show the basic block diagram of embedded system. The basic block diagram starts with processing. Here processing is nothing but a microcontroller. And next, in the input side of a processing having sensors, and the output side having LEDs or motors. And for all these functions, basically we have to need the power supply for the entire system. First of all, we have to take in the power supply to the processing, that is microcontroller. From the microcontroller we will giving power to the sensors, motors or LEDs, everything. Power supply is a basic thing. Here you see a pictorial representation of how the embedded system works. Here in the middle side we are having microcontroller, in the right side we are having sensors, and in the right side we are having actuators or dividers, in the left side we are having sensors. And in the next slide we have to see the in-depth of every component in the basic block diagram. That is, first thing is power supply. In the power supply we are including the bridge rectifier. Bridge rectifier means it can convert AC to DC by using 4 diodes. These are the pictures of how a bridge rectifier is. 4 diodes converts AC to DC, AC current into DC current. And next, the capacitor is used to store the energy, and an LED is used for the indication of power supply. The 12 volts input can be converted into the 5 volts DC currents and the 12 volts DC current. Here we see that the full wave rectifier converts AC to DC by using 4 rectification diodes. And next we see, first is power supply, it is completed, and next one is what is microcontroller. Processing means a microcontroller. In the microcontroller it can includes every components, that is analog to digital converter, oscillator, microprocessor, RAM, ROM, program memory. Everything can be integrated in the microcontroller. And next, the simple definition of a microcontroller. Microcontroller is a small self-contained computer system, plays a central role in embedded systems. That means it is the heart of the embedded systems. It can include both CPU, RAM, ROM, input-output peripherals. These microcontrollers are used to perform a particular task or function within a larger device. We use small computer in the larger devices to control. This is a representation how a microcontroller can having all these in a single thing. And next, this is the basic microcontroller, that is arduino. Arduino is a basic microcontroller. Every beginner can be learn embedded systems by using a basic microcontroller, that is Arduino. And in the next slide we have to see different types of microcontrollers. In these different types of microcontrollers, first of all we have to see Arduino. Arduino are different types. Arduino can be Arduino Uno, Arduino Nano, Arduino Mega. These are the basic types, are used for embedded projects and embedded applications. And the next one is Raspberry Pi. Raspberry Pi is a small mini computer. It is also a microcontroller. We can install Raspberry Pi desktop in our system for the processing. And in the next one is ESP32. ESP32 is also a microcontroller. It is in small size and it can having inbuilt Wi-Fi and Bluetooth. And in the next one we are having STM32. STM32 is also a microcontroller like ESP32. STM32 based on ARM Cortex-M processor. It is having high performance and a very speed performance. And next, PIC microcontrollers. These are 8-bit and 16-bit versions. They are very low cost. These are also microcontrollers we are using in our embedded applications. And the next one is 8051 microcontroller. These microcontrollers can be used in small and large applications in widely. Next, ESP8266. ESP8266 is same as ESP32, but ESP8266 having Wi-Fi only, but ESP32 is having Wi-Fi and Bluetooth. And next we have to see input and output. Input means nothing but a sensor. There are different types of sensors like temperature, humidity, color, smoke, touch, ultrasonic, infrared, everything. These are the different types of sensors. And in the next slide we have to see what is a sensor. A sensor is a device that detects and responds to the input from the physical environment. That means sensors can be used to detect the changes in the physical environment. The change may be a heat, light, motion, moisture, pressure, anything that related to the environment change. These sensors plays a vital role. Here we see that central processing of an embedded system is microcontroller. Next, sensor plays a vital role. These are different types of sensors like thermistor, IR, water flow, heartbeat, alcohol, LDR, LM35, smoke, gas, PR. These are different types of sensors we are having. And in the next slide we have to see what is output. Output means it is an indication to the humans. In the input, what are the changes occurs. It will be shown in the output side by using a buzzer, motor, LCD display, LED or anything. If you are using a temperature sensor in the input side, if temperature is high, in the output side in the LCD display it shows temperature is high or buzzer will on. Here we see that in embedded systems, actuators, buzzers, motors, LCD display are the examples of output devices. That means in the physical environment any changes occurs in the sensor side. In the output side, these are the components will show the output. And next we see the embedded systems applications. Basically we are having different types of embedded systems applications like CROs, smartphones, ATM cards, cameras, cards, everything, watches, traffic lights, fridges, washing machines, trains, metro, everything. Thank you for watching.